Welcome to the chapter on chemistry basics. Understanding the fundamentals of chemistry is crucial for chemical engineering students. This chapter covers the basics of chemistry, which will be applied throughout your studies in various chemical engineering applications. In this chapter, we will cover organic chemistry, inorganic chemistry, and physical chemistry. Organic chemistry is the study of carbon-containing compounds and their properties. These compounds include not only hydrocarbons, but also compounds with a variety of other elements, including hydrogen, nitrogen, oxygen, halogens, phosphorus, silicon, and sulfur. Hydrocarbons are the simplest organic compounds and consist only of carbon and hydrogen. They can be classified into three types: alkanes, which are saturated hydrocarbons with single bonds, such as methane and ethane; alkenes, which are unsaturated hydrocarbons with at least one double bond, such as ethene and propene; and alkynes, which are unsaturated hydrocarbons with at least one triple bond, such as ethane and propene. For example, the molecular formula for methane is CH4. Its structure can be represented as a central carbon atom bonded to 4 hydrogen atoms. Functional groups are specific groups of atoms within molecules that are responsible for the characteristic chemical reactions of those molecules. Some common functional groups include the hydroxyl group, represented as OH, found in alcohols like ethanol, C2H5OH; the carboxyl group, represented as COOH, found in carboxylic acids like acetic acid, CH3COOH; and the amino group, represented as NH2, found in amines like methylamine, CH3NH2. Ethanol C2H5OH is a common organic compound used in alcoholic beverages, hand sanitizers, and as a fuel additive. Its structure includes a hydroxyl group, making it an alcohol. Inorganic chemistry deals with the properties and behavior of inorganic compounds, which include minerals, metals, and organometallic compounds. The periodic table is a tabular arrangement of elements based on their atomic number, electron configurations, and recurring chemical properties. Elements are divided into categories such as metals, which are good conductors of heat and electricity, like iron and copper; nonmetals, which are poor conductors of heat and electricity, like oxygen and sulfur; and metalloids, which have properties intermediate between metals and nonmetals, like silicon and arsenic. Chemical bonding involves the attraction between atoms that allows the formation of chemical substances. The main types of chemical bonds are ionic bonds, formed when electrons are transferred from one atom to another, such as in sodium chloride, NaCl; and covalent bonds, formed when atoms share electrons, such as in water, H2O. Sodium chloride, NaCl, commonly known as table salt, is an ionic compound formed by the transfer of an electron from sodium, Na, to chlorine, Cl, resulting in the formation of Na+ and Cl- ions. Physical chemistry is the branch of chemistry that deals with the physical properties of chemical substances and the changes they undergo. It combines principles of physics and chemistry to understand how chemical systems behave. Thermodynamics is the study of energy changes in chemical reactions. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed. Mathematically, it is expressed as delta U equals Q minus W, where delta U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. The second law of thermodynamics states that the entropy of an isolated system always increases over time. Entropy, represented as S, is a measure of disorder or randomness. Chemical kinetics is the study of the rates of chemical reactions and the factors that affect them. The rate of a reaction can be expressed as rate equals K times the concentration of A, raised to the power of M times the concentration of B, raised to the power of N, where K is the rate constant. A and B are the concentrations of reactants, and M and N are the reaction orders. The combustion of gasoline in car engines is a chemical reaction that releases energy. The reaction can be represented as 2C8H18 plus 25-O2 yields 16CO2 plus 18H2O plus energy. This reaction involves the breaking and forming of chemical bonds, releasing energy that powers the engine. By understanding these basic concepts in organic, inorganic, and physical chemistry, students will be well prepared to delve deeper into the field of chemical engineering. Thank you for watching.